Okay, so to solve this, we need to cube both sides to get rid of the cube root, and we get 4x plus 1 equals 125. We subtract 1 from both sides, so we get 4x equals 124. We divide by 4, so we get x equals 31. However, we have to make sure that we check for extraneous solutions. So again, we are going to take and plug in 31 into our original equation. So the cube root of 4 times 31 plus 1, does that equal 5? 4 times 31 is 124. So 124 plus 1 is 125. We now have the cube root of 125, which is 5. So does 5 equal 5? Yes, it does. So our answer that we got of 31 is our correct answer of C. (17). We have to get rid of the square root, so we are going to square both sides of the equation. This is a binomial, so in order to square it, we have to add those parentheses. This is a perfect square, so we're going to square x, multiply together, and double to get negative 14x, square the 7. The square root and square cancel, so we are left with x minus 1. The left side looks like a quadratic, and in order to solve a quadratic, that means we move everything to that side, so we get x squared minus 15x plus 50 equals 0. This is easily factorable, so what are the factors of positive 50 that add up to negative 15? So we get negative 5 and negative 10. Setting each of those equal to 0, we get our zeros, or our solutions. So we get 5 and 10. Now, we need to check both of those numbers because, again, the method that we're using can cause extraneous solutions. So, checking 5. We plug it back in the original. 5 minus 7, does that equal the square root of 5 minus 1? 5 minus 7 is negative 2. So does negative 2 equal the square root of 4? Does negative 2 equal the square root of 4 is positive 2? So is that true? No, it is not. So 5 gets thrown out of our possible answers. We now need to check 10. So 10 minus 7, does that equal the square root of 10 minus 1? 10 minus 7 is 3. 10 minus 1 is 9. The square root of 9 is 3. Does 3 equal 3? Yes, it does. So 10 we get to keep as a solution. So our answer for 17 is C. Number 18. 18 has radicals on both sides. So we have to be very careful, or it doesn't have radicals on both sides, I'm sorry. We need to move it so that it has a radical on each side. So we're going to move this radical. So we get the square root of x minus 3 equals 3 plus radical x. We now need to focus on this radical because it is alone on one side and think, how do we get rid of that radical? To get rid of this radical on the left, we would square. So that means over here, my binomial also has to get squared. Square root and square cancel, so the left side is x minus 3. The right side I have to expand. It is a binomial, so square the first term, 9, multiply together the two terms and double, so 3 root x, so 6 root x when we double that, and then square the last term. Square root and square cancel, and we're just left with x. Now, move everything away from the remaining radical. So first, our x's cancel, because I have 1 on each side. Move my 9 over, I get negative 12 equals 6 square root of x. Divide by 6, and I get negative 2 equals the square root of x. I now have the radical by itself, so I'm going to start the process over of getting the radical away. So to get rid of this radical, I'm going to square both sides. Negative 2 squared is 4. The square root and square cancel. Now, I have to check the solution. So we are going to check 4 in our original equation. So the square root of 4 minus 3 minus the square root of 4, does that equal 3? 4 minus 3 is 1. The square root of 4 is 2. Square root of 1 is 1. 1 minus 2 is negative 1. Does negative 1 equal 3? No, it does not. So our 4 does not work. It is our only solution. So that means when I crossed it off, I have no other solutions. So my answer is D, no real solutions. Number 19. If we have this equation, what is the value of x cubed? You have to make sure that you are paying attention to the fact that it's asking for x cubed. We're going to solve for x first and then cube that answer. So, how do I get rid of a cube root? I cube both sides. So I get 12x plus 28 equals 4 cubed is 64. It's now algebra, so we go ahead and solve that. Move the 28 to the other side, we get 12x equals 36. Divide by 12, so x equals 3. Being diligent in what we are doing, we do need to check that answer. So we're going to check 3. So the cube root of 12 times 3 plus 28, does it equal 4? So the cube root, 12 times 3 is 36. 36 and 28 is 64. The cube root of 64 is 4. So, does 4 equal 4? Yes, it does. So this is what x equals. We're trying to find x cubed. So if x equals 3, x cubed should be 3 cubed. 3 cubed is 27. Answer is D.